Resume. All right, so if you want, if you have an image showing up on the whiteboard, all you have to do is click the minus sign and then the image will go away if you want full access to the complete whiteboard. That's up to you. All righty. So again, we're going to use the pullouts today. Hopefully you found yours since I misplaced mine. I don't know where to do with it. I'm in a small office, so. And we're going to do a quick review of what we did before the break and do a couple problems, and then we'll go into today's lesson of essential limit theorem. So before a break, we had a normal distribution, right? And it is always centered at the mean, and it has some standard deviation, right? That's what we were kind of doing before the break. And remember, we had 4 steps we had to do. Step 1, draw. Right? So we always draw our bell curve, and then we label with what we know. And you will always be given the mean, and you'll always be given a standard deviation, right? So let's say we have we're filling coffee because it's that type of morning, right? And so on average, we fill 16-ounce cups. And say that we're okay with having a standard deviation of 1/2 ounce, right? So we've drawn our bell curve and we have labeled our mean and standard deviation. And then we get asked the question. So what is the probability that a random selected cup has at most 15.75 ounces? So there's the question. What is the probability that a randomly selected cup has at most 15.75 ounces? So next, we're supposed to label 15.75. So if 16 is in the middle, 15.75 we'll say is about right there, right? Draw our line up. Now we have to ask ourselves, what does at most mean, right? So we think about that. It means at most is up to that number or less. So therefore, that tells me I color to the left. So we've completed step 1. Step 2, find z-score. Remember our formula, which is on our pullout under chapter 6. I think it's called a standard score. The formula is z equals x minus mu all over sigma. Again, I recommend that you put in the parentheses so that way you don't mess up your order of operations, because we must subtract first. And then now we start putting in numbers where we go. So the number from the problem, that is our x, right? That is our blue number here. This is x equals. So we have an x, we have a mu, and we have our sigma. So our problem is 15.75 minus 16 all over 1/2. And what does that equal?
0.5.
Equals what, 0.5?
Yeah. Or negative 0.5.
Negative 0.5, perfect. It does.
Yes.
All right, so we got a negative 0.5. anyone having any issues, any questions up to now, where we got that number? That is just making sure you plug things into your calculator correctly. So step 3, use table. So this is last time. This is where the negative matters, right? Because the negative tells me that I go to the negative z-score chart, right? And then we're colored to the left, which is what we're supposed to be on our chart. So that is all good. So now we just go to our chart, find negative 0.5, and what do we get?
0.3085.
What is it?
0.3085.
3085. All right, so there's one answer. And again, I don't have my chart because I don't know what I did with it in the last 10 minutes. So anyone agree with Virginia?
Yep.
Okay, good.
I do.
Right. I honestly have no idea what I did with my chart when I was looking for Brianna's homework. All right, so we're gonna go with that since I'm gonna waste time trying to figure out what I did with mine. Any questions? So that's all review. So hopefully everyone is kind of remembering this, and it has come back to how to use the table. So there is a 30.85% chance, supposed to be, of randomly selecting a cup, and that it'll have at most 15.75 ounces from this coffee shop. Everybody have this down in their notes before I move on? All right, I'm not gonna delete it. I'm just gonna go to a clean board so I can go back to it if we need to. So sticking with the same problem. 16 ounces. With a standard deviation of 1/2. Now the question will be, what is the probability that we have between 15.85 ounces and 16.10 ounces. So we finish and we draw. So 15.85, 16.10, and then we color in between. So again, step 1. Step 2, find z-score, right? How many z-scores are we going to have to find, though?
2.
2. So z equals parentheses 15.85 minus 16 all over 1/2. And then z equals 16.10 minus 16 all over 1/2. Just want to get negative 0.3. And 16.1 minus 16. keep trying to go to getting numbers that go into 2 decimal places, and I have yet to be able to do that. So we got negative 0.3 and a positive 0.2.
Yep.
And we go to our table. Step 3, table. Right? And so his table value and his table value. What do we get?
For the -3 one, we get 0.3821.
0.3821.
And then
Okay.
for the 0.2 value, we get 0.5793.
Perfect. We have an agreement.
Yes, I got the same thing.
Okay, good. Now what do we do with those 2 numbers?
You minus the 0.5793, you minus 0.3821 by it, and
Yep.
you get 0.1972.
So 19.72% chance that we pick a randomly cup of coffee that it will have 15.85 ounces to 16.1 ounces. Any questions so far? All right, I guess we're good to keep moving on then. So that's all been reviewed.
Mhm.
So to get into non-review now, we will go into what we want to cover today, which is the central limit theorem. So this is the new. So central limit theorem. And remember, if you go to the course page, under chapter, right under where it says syllabus, if you click on chapter 6, I have all these notes written out in a PDF version where you can kind of look. And then I also have a little place where you can post discussion questions if you want to, or you can email, either way. But it kind of gives us blurb about the central limit theorem, right? And typically when we do this class, I do a fun little experiment of rolling dice. I forgot to send an email to tell everybody to bring some dice. Maybe we'll do it next class, just to test their central limit theorem out. So for Thursday's class, try to make sure everyone, if you can, have a pair of dice, and then we will do a little central limit theorem experiment. But for today, we'll just kind of go through the calculations, and then we'll kind of play around with it next time with what it all means. So basically what the central limit theorem says, if I take some samples and then calculate their mean, the sample mean, and I do this over and over again, so over and over, the distribution of the sample means will be normal if the sample is larger. So what does that say? So basically what it says, if we take a bunch of samples of something and we calculate its sample mean, and then we take another bunch of samples and we calculate its sample mean, and we keep doing this over and over and over again, and we plot our means, the distribution or the histogram will look like the normal distribution. And so they have this thing called the rule of thumb. which is annoying that we also have another thing called the rule of thumb. But for the central limit theorem, the rule of thumb is n needs to be greater than 30. Unless, because there's always an exception, if your distribution, your sample from is already normal, then we don't really care what sample size we take. So if in the problem it says this follows a normal distribution, then our sample size could be anything. If it does not say our distribution is normal, then we must have a sample of at least 30. So if we have met those requirements, the central limit theorem says the mean of our x bars, our sample mean, so the population mean of our sample means will equal our population mean. And the standard deviation of our sample means will equal the standard deviation divided by the square root of n. So this is the first lesson that I think people start to get really lost in chapter 6. And it's, I believe it's because of the symbols look very similar and it's confusing which symbol means what. So I want to take a minute and kind of talk about that. So remember, mu by itself is the population mean. This guy is saying the population mean of the sample means. So the two symbols look very similar. The good news is they're equal. So the two figures are the same. The one that gets a little tricky is this bottom one. So remember, this is our population. I forgot to write the word mean. This is our population standard deviation. And this is our sample size. And then this guy here is the standard deviation of the sample means. And I know, again, this doesn't make a lot of sense, but I promise you give me 5 minutes, I think it will start to come together. So these formulas are also on your little pullout under chapter 6. So you notice there's basically 3 formulas in chapter 6 that you have to know. The z-score formula, that the two population mean and the population mean of the sample means equal each other. And then the standard deviation of the sample means equals the standard deviation divided by the square root of your sample size. So there's all the formulas you need for chapter 6. Now, I'd say, is there any questions? But I know there is. So let's just hold on for a second. Let's kind of do a problem and we'll see if this makes any sense. So I'm actually going to go right back to this problem. All right. I wish there was a way to copy screens, but I don't think I've quite figured that out yet. So we're going to redo this entire problem, but we're going to now apply the central limit theorem. So you're going to notice, remember, this answer was 30.85%. And we were picking a randomly selected cup. So we were picking one cup here. In our central limit theorem problem, we're going to do the same thing. So what is the probability that the sample means will, no, I forgot the number we used. Was it 15.75? Will be at most 15.75 if we select 49 random coffee cups. So again, we'll assume that the population standard deviation is still 16 ounces, right? Remember, this is mu. And then our population standard deviation, we said, was 1/2 ounce. So the steps are still the same. Step 1, we're still going to draw, right? So we take our X value of 15.75. We still have the words at most, so we're still coloring to the left. So we still did step 1. Step 1 is done. We drew it, right? Step 2, find our z-score, right? Remember, this is z equals x minus mu all over sigma. The problem now is we are of the sample means. So our new z formula is actually going to be x minus the mu of x bar in the standard deviation of x bar. So now we have to remember central limit theorem. So CLT. Mu equals, yeah, we'll make these not equal signs. Mu equals mu x bar, right? So that means our x is still the same. I'm going to run out of room. Let me clean this up a little bit. Our x is still the same, so 15.75. And because the central limit theorem says the mean of the population equals the mean of x bar, then this is still 16. So the two top numbers do not change even using the central limit theorem. What does change is the standard deviation, because the standard deviation of x bar equals the population standard deviation divided by the square root of n. So on my z, I have to take my 1/2 and I'm going to divide him by the square root of 49. And so I don't mess up any of my calculations. I'm going to put that in parentheses, and then I'm going to put that in parentheses. This is where central limit theorem gets a little tricky. So the good news is your numerator never changes. The only thing that changes is your denominator. So if we do our calculations out correctly, our new z-score is, let's see here. And you can type this, you're going to be doing these calculations while I do them as well, so we can make sure we all get the same answer. Ooh, this is ugly. So I get 0.04. Did anyone else get that with me?
Yeah. Yes.
Oh, okay, good. Made me nervous there for a minute. Anyone have questions up to this point?
It's 0.5 divided by the square root of 49, right?
Yep.
Okay.
Which is, I picked, that's perfect square root, so it's going to be 0.5 divided by 7.
So would the z-score be like, I got like 3 point something.
I got
Isn't that, like,
3.5.
It'd be like a
That's-
negative, right?
I got negative
I got a
3.5.
negative 3.5 as well.
That's what
I
I
got a
got.
negative 3.5 as well.
And then
I got
so,
0.071.
All right, here. What did I got wrong here?
that's why I was kind of confused.
Oh, I put a minus instead of a divide.
That's what I saw.
Right, because the numerator would be negative 0.25.
Yeah, that's not,
divided by
that's not supposed
really.
to, that is supposed to be a division, not a minus. Sorry, bad handwriting. Yes, so we get a huge z-score. Z-score of a negative 35. No, I don't. Right, I
Well,
can't
let's
say.
see.
No.
I was gonna ask, I think it's supposed to be 3.5.
Yeah.
Yep. I put my decimal in the wrong place. This is why we're practicing typing it in our calculators. Obviously, I'm doing horrible this morning as well. There we go. Yeah. So,
I don't know how you're getting 3.5. I'm not getting that at all.
Yeah, I'm
So,
not
it-
3.5.
so here we go. This is how I would type it into my calculator, now that I've fixed mine as well. Parentheses, 15.75 minus 16 divided by parentheses 1/2 minus, not minus, divided again, square root of 49, close parentheses. And if you do that all like that at once in your calculator, you should get
I thought it
negative
was
3 point.
yeah.
Yeah, you have to
No,
put the
division.
parentheses in.
Okay, now I got it. I was dividing it in parts. That's why I was doing the numerator, then the denominator, and then I.
Yep, and it will mess up the order of operations. That's why I wanted to make sure everybody has this. And even I tried not to mess up the order of operations, and I didn't mess up my order of operations. I typed in the wrong symbol, so that's even worse. But so that is your z-score. Make my thing a little darker. So now are we good?
Yeah.
Okay.
Yeah.
So I think I'm out of room on the next page anyway. No, I have too many blank pages in there. So when I move on to another, go back to our calculator problem. So this was all just still step 2. Now we're finally to step 3, table. So what is negative 3.5 in the table?
0.0001. There's an extra zeros. One more zero in there. Yeah.
So there's basically a 0.01% chance of getting, let's go back. So the probability of, if I take 49 cups of coffee and then I calculate their average, that they have 15.75 ounces or less, has a probability of 0.01%. Now, I've confused everybody since I messed up the calculations. The key words here. Anytime you select more than one, it is a central limit theorem problem. So the problems when you look into these will be very precise in how they're worded. What is the probability that A, meaning one, randomly selected cup has 15.5 ounces? This one, I forgot to put that piece in, but on the test and the homework, it definitely says those words very specifically. What is the probability that we have, again, we should add the words A randomly, we'll have between these ounces. That means we just do things the normal way. Then we get here, what is the probability that a sample mean will have at most if we select 49? We have now picked more than one, and since we've picked more than one, we must apply the central limit theorem. And basically the only thing we care about in the central limit theorem, the only thing that changes is we have to find a new standard deviation. Because in the central limit theorem, it said the mean equals the mean. Check. That means that number does not change, so we don't even really worry about it. The only one that actually changes is this guy. we must find a new standard deviation based on how many people or things or items that we're picking. Any questions? And we're going to do another one. All right, let's do another one and see if I don't mess up the math again. Let's go back to our GPA problem. I think we did this one before spring break, right? So if we assume the average GPA at CMCC is 3.7, right? With a deviation of 0.75. All right. So that, and we're going to assume normality. Assume normal. So we draw our picture. We have a 3.7 average with a standard deviation of 0.75. Okay. Now, where's the probabilities? A student has a GPA of 3.8 or higher. So I draw my picture. There's my 3.8. Or higher. There's step 1. Then step 2, find my z-score. So 3.8 minus 3.7, all divided by 0.75. And I'll do my best not to mess up the calculations this time. .13. Before I move on, I'll leave. All right, good. So now we do what?
Look at the
You have to find
positive
the
z-scores.
Yep, so we go to our table. Here's step 3. Find the value on the positive side of 0.13, and we get
0.5517.
0.5. We got 5517.
That's what I got.
Very good. Yes, we all get that number?
Yep.
Yep, that's what
So
I got.
it's fine.
Yeah.
All right. It seems awful high, though. I guess
For
no,
what?
sorry. It's almost at the mean. No, we're good. Because they're not far from each other from the mean, so we're okay. So, any questions on how we did that one?
So now for this one, since it's 3.8 or higher, do you have to do the complement of 0.5517?
You
Yep.
do.
Which equals 0.4483.
So why do we have to do the complement?
Because we're shading to the right,
That's correct.
and our things only shade to the left.
The 0.5517 is on this side. Remember, you pulled it from the table. That is to the left. You want its opposite, which means we do the complement. So to find this side, you do 1 minus 0.5517, and you get the answer of
0.4483.
Yep.
0.83. So 44.83% chance of finding a randomly selected student that has a GPA of 3.8 or higher. Good? All right. So we're going to do the exact same problem. I wish there was a way to copy the screen so I don't have to rewrite this whole thing. There's got to be a way to do this. Oh, well. We'll just go and do it again.
Mhm.
So assuming the same problem, but instead of picking one student, we're going to say, what is the probability (25 students have a GPA of 3.8 or higher? So again, we draw a picture. 3.7, standard deviation of 3/4, so 0.75. Put in our 3.8, color to the right. Now we have to find our z-score, right? But we have to do what first? What type of problem is this? So it's a central limit theorem problem. Why?
Because we have 25 students.
Because we have picked 25 students, right? However, we have a small issue here. What is our issue?
It's less than 30.
It's less than 30. But why are we okay?
Because it's a normal bell curve.
Because on the original problem, he had the words in there, assume normal. So because the parent distribution follows a normal bell curve, then we don't have to worry about the sample size. So we are okay. This is a central limit theorem problem. Therefore, my formula now is, and I'll put in the parentheses so we don't mess up our calculations this time, x minus mu all over, big parentheses, sigma over the square root of n. So I now have 3.8 minus 3.7 all over 3/4 all over the square root of 25. And I get 0.67.
Yep.
Yep.
All right.
Yes.
So then we go to our table. So this is all, so here's step 1, step 2, step 3 is our table. And we get 0.7486.
Yep.
And then we have to do an extra step this time, right?
Yep.
We have to do a special step 4 because this part is the 7486. So then for this is 1 minus 0.7486, which equals 0.214. So to answer our question, there's a 25.14% chance that if I randomly select 25 students, so basically the size of our stats class, that 25% of you will have a GPA of 3.8 or higher. Any questions on the central limit theorem problems?
How did you do that extra step at the end?
1 minus, we had to do the complement.
Okay.
Because we're colored to the right. Anytime we color to the right, we have to do the extra step. Because remember, every time we take a number out of the table, it is only to the left. So the 0.7486 we found is to the left on the table. But our question wanted to the right, so therefore we had to do an extra step. So anytime you do these problems, you have to do steps 1, 2, and 3. The only time you have to do step 4 is if you're colored to the right, like in this problem, or if you're between, like this problem, which is where we did the subtraction over here. So here is where we did step 4 in this problem.
Put that in
We
there.
subtracted.
This is not a toy.
All right. Any questions on anything we have done so far? Does anyone need any of these pages of notes before I move on?
I'm all set.
I'm good.
Because once I go out of this view, it
I'm all
erases
set,
them.
thank you.
And again, they'll be on the video. So I wish there was an easy way to get these, but they're not. All right, so what I want to do now is I'm going to stop sharing that. I am then going to share my screen. All right, can everyone see my Excel?
Yep.
Yes,
All right.
I can see it.
Yep.
So here is the little, if you want to use Excel instead of the tables. So if you type in, again, an equal sign, and you have norms dist. And notice Excel asks for the z-score, right? So our last problem, our z-score was 0.67, correct? So if I put in 0.67, I get the same answer that you got in the table. So again, norms with an S, dist, will give you, Excel will give you the values out of the table, right? Now, to make this even easier, I'm going to type some of the problems in here. So we had a mean of, what was our mean? 3.7. And we had a standard deviation of 0.75. And we picked how, and then I'll do it twice here so we'll see both answers. And then first our size was 25, right?
Mhm.
So our first question was, what is the probability that X is greater than 3.8? No equal sign, 3.8, right?
Mhm.
I'll just put this inside there, the probability greater than 3.8. So to actually solve this in one step in Excel, I type in equals, and I take the norm dist without the S. Now you can see it needs a lot more information, right? It needs our X, which was 3.8. It needs our mean, which was 3.7. It needs our standard deviation, which was 0.75. And then it is always cumulative, so I always put a 1 in here. So again, to recap, do norm dist, put in your X, then your mean, then your standard deviation, and then a 1. And there is the 0.55304. And because it's greater than, I have to do the complement of that, so 1 minus, and there is the answer we got earlier. If we have to do the central limit theorem problem, right, equals norm dist again. X is still 3.8. Our mean is still 3.7. Oh my God, 3.7. Our standard deviation, though, because it's a central limit theorem problem, now changes, right?
Mhm.
But this is XL, so if I put in 0.75 divided by SQRT of 25, I don't even have to do the calculations. Excel will do everything for me because that is the new standard deviation according to the central limit theorem. And then I put in my 1, and there is the same answer we got before. Now, notice this answer and that answer are not the same. The problem with the tables is you have to round to 2 decimal places to use it, correct?
Mhm.
Excel does not round. Not draw. Let me erase my writing here. Excel does not round. So it found the exact answer. Now, it's not a huge difference. I have 74.9% and 74.8%. So it's a 0.1% off in values. So when on the test, I will make sure that I take people's answers that do the table, and I will also take people's answers who use technology. Both will work. So if you are like using Excel to do calculations, you can see that I don't have to use the z-score formula anymore. I can just use the norms dist function in Excel, and it does it all for me. However, if you like to do things by hand and keep doing the step-by-step procedures, then I would definitely do what we've been doing. Now, if you are going to use Excel, I would still draw a picture, because if I don't draw a picture, 0.74 is not the correct answer, right? We still have to do what?
1 minus.
We still have to do the complement. So even if I use technology, I highly encourage you to draw a picture, because Excel is not going to ask you, did you want left or right? Excel is just going to do what you tell it to. So by drawing the picture, it will remind you that you still have to do that extra step. The only thing technology does for you is you don't have to do step 2 anymore, but you still have to do steps 1, 3, and 4 every single time. Oh, excuse me, every single time. So I don't have a preference which way you do it. I would say find the one you're comfortable with and stick with it. Whichever one you use for the homework, that should be the one that you use for the test. Any questions? So this has also been recorded, so this will be part of the video. So at the end of the lecture, you can fast forward to near the end of the hour mark, And it kind of goes through, again, how to use Excel. And there's videos posted on just how to use Excel as well. So if anyone doesn't need anything more in this, I'm going to stop sharing this screen. Go back to Zoom. And see, do you have any questions? I think we covered a lot today, so I'm probably not going to go the full 90. I will use this last half hour to answer any questions that people may have. Or if they want to do another problem because they're still unsure, then I will do another problem with you. But that's all the new material I'm covering today. Remember, if you owe me late work, please get it in. So the fact that we can get caught up. Grades have all been updated. I would definitely start on homework 3. Your choice, Pearson or my coursework. Of course, the test this time is going to look a little bit more like Pearson. So I would